Hi there, folks. Root Beer here, looking at question number 19 on the 2006 Fermat paper. So, question number 19. In the diagram, triangle ABC is a right angle. Fair enough. Side AB is extended in each direction, so we basically sort of have, it looks like an XY axis almost. But it's extended to D and G in both directions, and such that, we've got some conditions here. DA equals AB equals BG. So these guys are each the same length. Similarly, BC is extended to F and K, so that those are each the same length. And AC is extended to points E and H, so that these three are the same length. The ratio of the area of hexagon DEFGHK to the area of triangle ABC is okay. Probably gonna have to use some congruent triangles here. Why don't they use I? Why is it K? I think I've seen them use I in the past. Anyway, small quibble, nothing to worry about. All right, let's copy the picture down. So D, G is A, B, C. I'm going to guess E and F, but maybe I'm wrong. I was. E and F went the other way. E, F, G, H, and then for some reason K, but not I. Alright, so they haven't shown us the actual hexagon that we're working with. It's going to look like this. And likely the reason they haven't shown us it is because it's going to very quickly help us figure out the answer. Now, you might say to yourself, well, D and E are going to be the same height here, so this is going to be right angled. But you don't actually know that. Like, you haven't actually shown that. It just looks like it. But before we get into it, I'll show you exactly how I'm thinking about doing this one. Dropping perpendiculars there, perpendicular there. One here. I'm just going to carve this thing up into multiple copies of ABC. That way it's going to be very easy to determine the ratio. So in fact, if we want to do this quickly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13... should be 13 ABCs to 1 ABC. The answer should be 13 to 1. Is that even a possibility? Yes, there it is. It's E. So if you did it that way, you could very quickly get 19. I'm going to blabber on for a little bit now, explaining exactly why this will work. But for those of you who made that connection, 13 to 1, you're done 19, boom, you're already at question 20. And if you want to stop the video and look at question 20, go to the next video, which will be question 20, by all means. But if you want to stay, I'm going to talk a bit more about why this is going to work. All right, so thanks for sticking around. How do we want to say this? So it's mostly just going to be chasing. So I've got my basic carving things up already written down. I suppose we can be a bit more accurate. I want the line going through C that's perpendicular to BK. So it'll be perpendicular here. So I get some right angles here. And I want this line going through perpendicular there. And I want this line to be parallel to this line. I think that should be enough information. Okay, so we know that AC is the same as CH, which is the same as AE. And we know DA is the same as AB. And look here, we've got intersection of lines, so we'll use another color. We use this yellow. This angle has got to be equal to this angle. So now we've got side, angle, side. These guys are going to be congruent triangles. So ADE is congruent to ABC. Okay, so we really do have a right angle here. Okay, what else can we do? So get a right angle here and a right angle here. This angle is going to be the same as this angle. And since I've chosen these to be parallel, they're going to be the same as this angle up here. And I know... Oh, actually, what have we got? No, we used purple, didn't we? So the purple lengths are the same, and now we need another color. We'll say green. Each of these green lengths is the same. So I'm gonna fill in the ones that we've got worked out. We know by side angle side this is the same as this one. And now by same side angle side result, because we got a right angle and we've got the green and the purple, we know this is the same. What else can we do? Maybe not do this one. Yeah, we won't do these. We'll do these. So, same thing, right angles. We've got right angles here. And we've got the blue, or sorry, we got the purple and the green line. So, again, side angle side tells us these are the same. Okay, so that means that these are both the orange hypotenuse line. Alright, now what else are we to do? So we'll get rid of this one, because I don't want to use it yet. Oh, and we've got... So this blue angle is opposite this blue angle. So we've got another side angle side says that CKH is the exact same. Alright, so we're slowly working these guys up here. Now, what else are we to do? So that means that this line here is purple, and we've got a right angle here. So that means G and H is a nice little horizontal line. So I can drop down a perpendicular, and this is also going to be the purple. And so once again, really a side angle side will get you these are the same. Now how about anything with the D and the K? Well, DBK is similar to ABC by a ratio... I haven't written any sentences yet, by a ratio of 2 to 1, because you notice it's 2 of the blues, 2 of the purples, and it's a right angle triangle. So we use the off pink. This is actually 4 copies of ABC up here. So we got 4 of them, 1, 2, 3, 4, 5, 6, 7, so 4 plus 7, so we've got 11 of them so far. Now, going back to our green, we said that ADE was similar to ABC, so we get this green line here. That means that EF is parallel to DG. So we get some nice right angles here. So now I can drop another right angle here. And once again, by side angle side, we're going to get the other 2 left. So that's a far more detailed and actual, like if you wrote out my argument with a whole bunch of words like side angle side, I didn't feel like writing that, but we can much faster, or not much faster, but much more accurately calculate that it is 13 ABCs that are the whole area And then, well, let's actually finish it off with the area calculation. But the idea here is now, so area of DEFGHK is 13 ABCs. So the ratio is area of 13 ABCs to 1 ABC divided by ABCs, we get 13 to 1, and I did say that that was E as our answer. So if you actually wrote down my verbal argument, I did justify everything, so this would be fine for a written question. Say you encountered this on the Hypatia, where you actually have to justify everything rather than the Fermat, which is just find the right answer. You would be able to get everything. So this all boiled down to one similar triangle and a whole bunch of side angle sides. The reason I had to use a similar triangle, I think, is I could extend these lines here, but there's no immediate guarantee that it's not going to actually sort of extend beyond and still be contained. There's no reason it should lie on that line. So you'd have to use a slope or similar triangle argument there as well. I suppose you could probably say go this distance along here, side angle side, that's going to have to be the purple, and so it's going to be right angle. So that would be fine as well. Lots of ways to do this. You could just go for the straight. Gee, I understand it's going to be congruent triangles, connect, actually draw your hexagon, and then break it down into the appropriate areas, count them, 13 to 1. That was the answer very quickly. But now I've verbally justified everything using a whole bunch of side angle side. And that's fine. You don't need to go through that detail except to satisfy yourself and to say, yeah, I definitely have the right answer when you're doing a multiple choice contest. You get the answer, however fast you get it, as long as you know the answer and you're comfortable bubbling it in and just leaving it there, then by all means, just bubble it in and go with the shortcut. So we spent a long time on this question. That was question 19. And we're going to, I sort of lost room there, so we're going to flip the page. We got one more question to go in part B, and that will be question 20. I will see you guys for that one in the next video. Ta-ta.